Good morning, everyone. Due to some technical reasons, in the last class, whatever we have discussed, the video has not come, only the audio has come. So, I have asked Manoj to just whatever I have taught in the previous year's classes. So, those videos have been updated. Okay. If you have any problem anywhere understanding anything, uh, because that is only a short lecture. So if you have any problem in the understanding, let me know. We can cover it at some other time. Okay. So continuing with the chapter. So the next topic is the convolution. Okay. So in our last class, last couple of classes, in fact, we have been discussing about the convolution, right? So we discussed that when we talk about convolution, it helps us the convolution technique. It helps us in calculating the output of the LTI systems. Okay. So it can be performed either through the DFT method or in the time domain method. In our last class, we have seen how the convolution can be performed, or the output of the LTI system can be uh, computed using the DFT method. So you have the input, we have the output in the we have the this impulse response of the LTI system. Then what we do, we perform the DFT of the XN and the HN, which are basically the inputs and the impulse response. Then we multiply both of these to get the output in the frequency domain. Then we perform the IDFT, right? So this is the whole method what we do to find out the output of any given LTI system. Now today we will be looking into the convolution, wherein we perform this convolution to find out the output of the LTI system in the time domain. We don't have to go into the frequency domain to get the output. Okay. So the first method, it is the sliding tape method. Okay, sliding tape method. So in the sliding tape method, if you see, we are given with an input signal x of n, and then we are having an LTI system which is having an impulse response of hn. So output, it will be given by yn equals to xn commutation, this convolution of h of n. Okay. Also, if you look over here in this equation, what we have written, yn equals to xn convolution of hn and also hn convolution of xn. That means this operation, convolution, it is commutative in nature. Okay. So let us take an example where we are given with the input signal x of n, where we have 1, 2, 3, 4, and 1 is at the origin, and also we are having the impulse response 1 to 1. Okay. So for performing the convolution, what we need to do, we need to find out h of minus n, which is basically the time inversion. Okay, we have already discussed about the time inversion. So we have to find out h of n. Okay, so here I am talking about when we will be performing the convolution using this first method x of n convolution of h of n. Okay, so whatever would be the second number, over there you have to perform the time inversion. However, suppose if you write h of n convolution of x of n, then what you have to do, you have to find out x of minus n. Okay, time inversion will be for the xn. Okay, so this you have to keep in mind. Time inversion would be for the signal component which is coming in the second instance and not in the first instance. Okay. So that's why if you see, we have calculated h of minus n. Now if you see, if we find out the h of minus n, then we get 1 to 1. Now since it is the time inversion, basically across this instance, the values will be mirroring. So now the new origin for h of minus n, it would be the one on the right hand side, because this 2 it is going to minus 1, and this one it will be going to minus 2. So this is minus 2, n equals to minus 2 minus 1 0. Okay, so this is 0 1 2. Okay, so once this happens, so once we have this, so how to do the calculation? Okay, so if you look into the calculation, you will put your xn values. So xn is given by 1 2 3 4. Okay, so 1 is the origin, and then we are having this h of minus n. Now we will write h of minus in such a way such that the origin of x of n and the origin of h of minus n, they superimpose or coincide. See over here, it is superimposing. Okay, now these were blanks, so blank means 0. Here also these were blanks, so blank means 0. So what we have to do now, we have to multiply and add. So multiply xn and h of minus n values, then addition of the next xn and hn values, then again next. So what we have here for y0, we will be getting 0 multiplied by 1 plus 0 multiplied by 2 plus 1 multiplied by 1 plus 2 multiplied by 0, and so on. Okay, so am I clear till now? Okay, so in this way we will get this equation. So only this is the legible one, 1 multiplied by 1, so it comes out to be 1. So we will put it as y0. Why? Because when both the origins are matching, that is constituted to be y of 0. That is constituted to be or considered to be y of 0. Okay, now next what we'll do, as the name suggests, sliding tape method. So we are considering xn and hn to be the tapes. Okay, now we will move any one of the tape. So we will consider h of minus n as the movable tape, and then we will be moving it towards the right. And when we move it towards the right, we get this information, this signal component. So for when we are moving the signal h of n towards the right, then there is an increment of n by a value of 1. Okay, so we are having 1 y of 1 equals to 1 multiplied by 2 plus 2 multiplied by 1. Okay, again 2, so this comes out to be 4. In the next class, what we will be having, we will again move this tape over here. So we will be having 1 to 1. So see, 1 multiplied by 1 1, 2 multiplied by 2 4, 3 multiplied by 1 3. It comes up to be 8. In the next instance, we will again move this step towards the right. So we get 4 multiplied by 1 4, 3 multiplied by 2 6, and 2 multiplied by 1 2, which is 12. Again we will be doing this, moving the signal to the right to get y of 4 and then y of 5. So this is becoming 8 plus 11, and y of 5, it is becoming we get 4, because this one 1 to 1, it will come like that. So 4 multiplied by 1 4, and the rest would be 0, right? So what happens over here, we get an output y of n equals to 1 4 8 12 11 4. And where is the origin? Origin is this one. Okay, origin is this one. So what is the length of this signal? If you see, the length of the signal is 1, 2, 3, 4, 5, 6. How did we get that? We got that by from the length of the x and length of the h. So if you are given with the length of the x and length of the h, we can find out the length of the output also, which is given by length of x plus length of h minus 1. So 4 plus 3 equals to 7 minus 1 6, right? So that's why we got the length of yn as 6. Okay, it is not important at this stage, but at a later stage why it is important we will get to see. Okay, now herein if you see, what is happening over here is that in both xn and hn, the first numbers, they were the origin values. Okay, we are having origins at the first instance. So what happens, suppose if I take the origin to the second instance, so n equals to minus 1 0 1 2. Okay, so what will happen, same process, while we will be doing the initial mapping. So this is the 0, after inversion this is the 0, so this 2 and this one should overlap. Okay, so at y0 we are having 4 initially, at y1 we are having 4, but here at y0 we are having 4, right? Similarly, as you go on increasing y0 1 2 3 4, we get the values. But after we are done over here, we have to also go towards the negative side. Okay, so this is the this thing, then we have to move it to here, so it would be 1 to 1, so y of minus 1, it becomes 1. Mm-hmm. Convolution is from minus infinity to plus infinity. So when you are moving towards the right hand side, you are going towards the infinity, plus infinity, n equals to plus infinity. So you have not calculated for the, you have calculated from 0 to infinity, but you have also have to calculate the things from n equals to minus 1 to minus infinity. That's why you have to move the tape towards the negative infinity also, right? So that is the reason. So once you have this one, so output, if you see, you have got this thing, and you know from here we have calculated wherever the n value would be 0, we will be putting the pivot point, that means the origin, right? But in some other cases we will find, say for example in the matrix multiplication application method, uh, you will not be able to get that. But is there any rule by which we can exactly tell that this is the position where I can put the origin values? Okay, so for that there is a rule. So if you see n of x, what is n of x? N of x is number of values after the origin. So number of values after the origin in x is 1 2. Okay, so n of x is 2. Similarly, n of h after the origin, how many values are there? 2, right? N of h is also 2. So nx plus nh, it is equal to 4. Okay, nx plus nh, it is equal to 4. So we got this magic number. N is the number of values that are present after the origin value. after the origin value, whatever the number is there. Okay. So we have got this magic number of 4, right? So after you get the signal, you will count from backwards 1, 2, 3, 4. Then the next number would be the origin. Okay. The next number would be the origin. Are you getting my point? Any confusion till now? Okay, good. Now let's come to the tabulation method. So we have this linear convolution method. See, we are having 1, 2, 3, 4, 1, 2, 1. Okay. So this is x of n, values of x of n has been put, and this is h of n. So now we will be doing multiplication of each row value with the column value. So 1 multiplied by 1, 1, 1 multiplied by 2, 2, 1 multiplied by 3, 3, 1 multiplied by 4, 4. Similarly, 2 multiplied by 1, 2, 2 multiplied by 2, 4, 2 multiplied by 3, 6, and so on. Done. Now we will be drawing some diagonal lines like this. So what is this? See, 1, it comes over here. Now these two 2's, they are in the same diagonal. 2 plus 2, 4. Then 1 plus 4 plus 3, 8. Then 2 plus 6 plus 4, 12. 8 plus 3, 11. 4. So this is the tabulation method for performing the linear convolution. Okay. Now over here, there is nowhere that you can mark the origin values. Now the information what we got in the previous slide, that will be helpful for us over here to place the pivot to mark the origin value. Okay. यहाँ पे, if you see, in the second, over here we have marked this thing, and accordingly we have calculated y0, y1. So y0 was quite what do you call it? It was quite legible, right? We knew from the beginning that this value, this 4, it would be forming the origin. But in this over here, there is nothing. So in the output we have to put. So depending upon whatever the formula I have told in the previous slide, you have to put the origin. Okay. So suppose both hn and distance over these are the origin values. Then we will be having 1, 2, 3, 4, 5. So after 5 values, we will be placing the pivot 1, 2, 3, 4, 5. That means over here. Okay. Suppose the origin value was here, then we would have 1, 2, 3, 4. Again, we would have put over here. Say for example, the in the xn the origin value is at 1, and uh, the origin value in hn it was at 2. So again 1, 2, 3 plus 1, 4. So again the origin would have been at 4. Okay. Now then is another type of convolution which is regarded as circular convolution. Okay. In the circular convolution, what you have to do is that the length of both the signals, in this case x of n and h of n, should be the same. Herein the length is 4, here the length is 3. So we have to make this signal h of n and convert it into a signal having a length of 4. Okay. So how to do that? So 1 to 1 comma 0. We just added a 0 which is called as 0 padding. So we just added a 0. So it is not affecting the signal HN. The main signal component, it remains the same. Okay. So it is not affecting the signal, but without affecting the signal, we have converted it into a 4-point signal. Okay. Now we will make the matrix of xn, wherein all these values, they will be put in the column wise format. Okay, 1 2 3 4. Then what you have put, the last number, it would come to the first. Okay, then all of this, again this last number, it will come to the first. Okay. The other numbers, they will move diagonally down. Again this last number, it will come. Now if you see this diagonal, it is having the same value. So the row by column, it is becoming 4 by 4. Similarly, this HN, this thing, it has to be put into the column wise manner, but it will be having a row by column of 4 by 1. That, so when we multiply two matrices, the row of first one and the column of the second one decides the what should be the size of the final output. Okay, so here the final output, it would be having a row of 4 by 1. Okay, now I hope every one of you know how to do the matrix multiplication, right? All of you know how to do the matrix multiplication. So after doing the matrix multiplication, we get this thing. So this is 12 8 8 12, right? Now the problem over here, if you see this output and the linear convolution output, they are totally different. Okay, they are totally different. So in circular convolution, we have to keep it in mind that whatever is your input size, you get an output of the same size. Okay. However, in the previous slide, we have seen, when we are talking about the output of the linear time invariant system, LTI system, the length of the output, it is dependent on the length of the x and length of the h. Okay. So by this equation, we get the output signal. Okay. So not equation, by this formula we get the length of the output component. Now if I ask you to perform to find out the output of the given system through the circular convolution, how will you do that? We know the previous formula, Ly equals to Lx plus Lh minus of 1. We will simply apply that formula. So what it does, 4 plus 3 minus 1, it would be 6. That we know. So we will convert the xn, into a signal component having a length of 6. How will you do that? We will add 2 more zeros, zero padding, okay, to the x. Similarly, the hn should be having the same number of values. So over here we have to add 3 zeros. Okay, and the rest of the method, it remains the same. This n0, it comes over, and all the things, it goes diagonal. Then again it goes over here, and the number repeats itself. Okay, see, this one, it comes over here. Now next this 4 comes over here, then this 3 comes over here, then this 2 comes over here. So you have to see this whatever is your 0 0 coordinate, it comes into the as the last value also. Till then you have to just rotate the number, and when you have done this, you see we have got that magic sequence of y, right? We have got the magic sequence of y. So this is called the implementation of linear convolution by circular convolution.
सर अगर ये वाला मेथड से निकाल रहे हैं हम लोग और सर सर्कुलर कन्वोल्यूशन का सर मतलब क्या होगा सर लीनियर कन्वोल्यूशन से हम लोग को ये मिल जा रहा है सर मुझे सर्कुलर कन्वोल्यूशन की उसका सर वैल्यूज गलत है मतलब
हाँ, that is a method. Circular convolution is a method. So this is,
गलत आता है तो फिर करके क्या फायदा
I never said that output is wrong. I said that output of a system can be given by linear convolution only. Okay, so this is a circular convolution. This is just a method. So over here, if you see, I have written linear convolution implemented by circular convolution method. The output of a given system, it is only be computed through the linear convolution. Okay, herein we are using or we are modifying the circular convolution so that we can implement the linear convolution. Okay. If I just ask you to perform circular convolution, so you need to perform these things. You need to check both the sizes. Okay. So if one of the size is smaller, you that signal whether it is xn or hn, you just pad it with zeros. So to make both the signals as same length signal, and then you perform linear convolution. Oh yes, circular convolution. Sorry. Okay. However, if I say that you find out the output of an LTI system, then you have to find out Lx, you have to find out Lh, then you have to find out Ly, and there using this Ly component, Ly equal to 6 or whatever number you get, you have to pad both the numbers such that you get to this magic number of Ly. Okay. Am I clear? Okay, good. Now comes to the equation part. I came to this part at the last. Why? Because I wanted you to understand what is the mechanics behind this calculation. Otherwise, you would have been just mugging up, right? So, what is happening over here? We are having xn, we are having hn. Now, all the textbooks they will give you this equation: yn equals to summation of m equals to minus infinity to infinity. You are telling why we should go to infinity or minus infinity towards the left hand side. This is the reason. This is the mathematical equation. Summation of m of minus infinity to infinity x of m h of n minus m. Okay, h of n minus m. So why h of n minus m? Because if you remember, in the previous section what we have done, we have inverted the time. So when we have inverted the time, we have changed the time axis. So this time axis is being changed due to this reason. That is being incorporated over here, x of n multiplied by h of n minus m. Now you need, in both the cases, if you see, both are time limited signals, they are present within the time. So what should be the values of these limits? Minus infinity to infinity, you can go, but we have seen in our previous cases that the signal, they are available within particular time limits, right? So we cannot do all the calculations from minus infinity to infinity because those values will be zero. So we need to find out those limits. How to find out those limits? The limit is m values ml, it will be equals to x of l Okay. In this case, what is x of L? X of L is minus 1, value of n. M is time. Do you remember? M is time axis. M equals to, we have to see it from the x value. Okay. So from the x signal, we have to find out this. ML equals to x of L, which is equal to minus 1. Then m of h, higher component infinity, towards the infinity, what will be having? X of h, x of h is 0, 1, 2. So 2. So from x of n, we have to calculate this ml values, ml lower limit and higher limit. The lower limit of xn is the lower limit of m. The lower limit of the n value of xn. Okay, that is equal to the lower limit of m, and the higher limit of xn, the higher n limit of xn, it is the higher limit of m. So now we know that this m, it will be varying from 1 to 2. Done, right? Now coming to another variable, which is the n. How the n will be varying? NL means the lower limit of n, it be x of L. X of L is minus of 1. H of L, H of L is 0. So minus 1. N of H is x of H plus H of H. It is 2 plus 2, 4. Okay. M value will be calculated only from x of n, and the n value, it will be calculated from both xn and h of n. Am I clear? Now once you get that, you have got the n values. M values, we know that n values will be changed from minus 1 to 2. So we know the lower value of n is minus 1. So y will be minus 1. This equation is m equals to minus 1 to 2, and n value I have put as minus 1. You just put the values over there. So by putting this, we get x of minus 1 multiplied by x of 0, h of 0 plus x of 0 multiplied by h of minus 1, and like this. So what you get over here, 1 multiplied by 1 plus 2 multiplied by 0 plus 2, which is 1. So if you see over here, I have just plotted it from the sliding tape method. This is h of 0 when we are having both the origins at the same place. Y of minus 1 means we are at this position. So see, same here, 1 multiplied by 1. When we go to y0, see, y 1 multiplied by 2 plus 2 multiplied by 1. 1 multiplied by 2 plus 2 multiplied by 1. This is 4. Similarly, you have all these other numbers, and then we get this output, right? Then we get this output. This is all about the convolution. Any questions? Now you can calculate the other values using those equations, and also you can practice the other of these things. Definitely.